Hello Year 8. Today we are doing a lesson on area and we're going to be finding the area of squares, rectangles, triangles, as well as composite shapes. The formula for the area of a square is A is equal to S squared, S being the side length. The formula for the area of a rectangle is A is equal to BH, and the formula for the area of a triangle is A equals to half BH, which can be written as BH over 2 if you prefer, but I'll be using the highlighted version of that formula. Composite shapes means combining two shapes together. If they are next to each other, like the one that's shown here, you would find the area of those two shapes and you would add them together. If you had one shape being cut out of another shape, you would subtract the big shape minus the smaller shape. We also need to convert between units of area. So these will be things like millimeters squared, centimeters squared, meters squared, and kilometers squared. If you remember the normal millimeters, centimeters, meters, and kilometers, you'll remember the 10, 100, 1,000, but when it's squared, you just square all of those numbers. We're also going to be talking about hectares in a few questions. If you need to convert between meters squared and hectares, hectares is a unit that we usually use to measure land. So there is 10,000 meters squared in a hectare. So if you have meters squared, you divide by 10,000 to get to hectares. Or if you have hectares, you will times by 10,000 to get to meters squared. Okay, on the next page we have more. These are some new ones. We have a parallelogram, which is A equals BH, a rhombus, which is A equals half XY. The X and the Y are the diagonals, so X is going from one side across to the other, Y is the other diagonal. And it's half X times Y. A kite has the exact same formula, A equals half XY, and again they are the opposite, joining of the opposite corners, making those the diagonals of that shape. A trapezium, which is a shape that has one pair of parallel sides, the formula is H over 2 bracket A plus B. The H is the height between the two parallel sides. The A and the B are the length of the two parallel sides. Okay, here we go. Time to convert. Question number 1. Convert these to the units shown in the brackets. We want to convert 0.578 meters squared into centimeters squared. When you look at the chart that we had on the previous page, to go from meters squared to centimeters squared, you have to times by 100 squared. Okay, you can type that into your calculator if you need to. It would be 0.578 times 100 squared, which is 5,780 centimeters squared. Question B. We want to go from millimeters squared to meters squared. That's going to be two jumps. If we look back at our diagram, millimeters squared is here, and we want to have to go through centimeters to get over to the meters. So we need to divide by 10 squared and then divide by 100 squared. So type that big long thing into your calculator, starting with the number 65100. We're dividing by 10 squared, and then we're dividing by 100 squared. And that's equal to 0.0651 meters squared. Question 2, find the area of the following. So there's going to be a lot of different shapes here. And every time you see these kinds of questions, I want you to do 3 lines of working out. The first line is the formula. You need to be able to correctly identify the shape and know which formula to use. This first shape is a triangle. The formula for a triangle is A equals half BH. The second line of working out is that you want to substitute into that formula. The b and the h, which is the base and the height, will be, the base can be 21 and the height will be 19. So we'll have half times 21 times 19. And then the third line is that you want to calculate what that is equal to. So in your calculator, it equals 199.5 centimeters squared because it's area. Shape 2 here is a rectangle. The formula for a rectangle is A equals BH for base times height. The base and the height will be the 5 and the 10. So second line, we sub in 5 times 10 or 10 times 5. It doesn't matter which one goes first. And that's going to be equal to 50 centimeters squared. On the next page, shape C here is a triangle. It's just that it has a big obtuse angle in it, making the triangle slope out to the side here. The formula for a triangle is always half BH. Now this triangle is trying to confuse us because there is 3 sides on here. The base and the height are always joined by a right angle, even if it's been extended out the side of the triangle. So the base is going to be 80 and the height is the 1.2. However, that's in meters, so let's make our units the same. Let's convert 1.2 meters. If we times that by 100, that would be 120 centimeters. Okay, so half times the base, which is 80, times the height, which is 120. Calculate, that equals 4800 centimeters squared. Question D is a square. The formula for the area of a square is A equals S squared. S for side length. My side length is 12, so it's going to be 12 squared. And 12 squared is 144, but you might want to practice the squared button, so it's here with the x to the power of 2, so you push that, that's the squared, and there's the 144 millimeters squared. Question E. This shape is a parallelogram. So it looks a bit like a rectangle, but it's been pushed over so that it doesn't have right angles, so that's a parallelogram. The formula for a parallelogram is A equals BH. The base and the height, again, we have 3 measurements here. The base and the height will be connected by the right angle. So it will be the 15 and the 5 that are joining that right angle. So the 7 is an extra number there that we don't need. So base times height will be 15 times 5, which is equal to 75 centimeters squared. F is a trapezium. The reason I know it's a trapezium is because I have this pair of parallel sides here, and I have the height between those 2 sides. So the formula is A equals H over 2 bracket A plus B. The H is going to be the 3. The A and the B are the 2 parallel ones, the 7 and the 11. Let's sub it in. H is 3 over 2 bracket A is 7 plus B, which is 11, close bracket. Then we're going to put that in our calculator. 3 over 2 times the bracket 7 plus 11 is 27 meters squared. G. This shape is a kite because you have the 2 smaller sides at the top and then 2 big long ones underneath here. The formula for a kite is A equals half xy. The x and the y are the diagonals, so this diagonal is 6 and this one is 8. So it will be half times 6 times 8, which is equal to 24 centimeters squared. H. What shape is H? Looks a little bit different from the last one we saw, but that is a trapezium because we have these parallel sides here. So I'm going to need the 13.5 and the 6.3, and I need the height between them, which is the one with the right angles. This 11 is a distraction. Please don't use that one. It'll make our answer wrong. So our formula for a trapezium is A equals H over 2 bracket A plus B, close bracket. The height is the 8.4 over 2, and then bracket the A and the B, the two parallel ones. It doesn't really matter which one you put first. So I'm going to go 6.3 plus 13.5, close bracket. That is equal to, when you put it in your calculator, 83.16 meters squared. On the next page, this is our first composite shape, because it's not just a rectangle or a triangle or any of those other shapes. We have two things combined here. So I'm going to cut this shape into pieces that I have formulas for. So I'm going to cut it down here. So I have rectangle number 1, and I'm going to have rectangle number 2. The formula for a rectangle is A equals BH. Then I'm going to add to that another rectangle, which also has the formula BH. But this is going to be my first rectangle, and this one's going to be for my second rectangle. We're going to add those two things together to get the total area. So looking at my first rectangle, the base and the height, now remember my rectangle only goes to this green line here, so the 10 goes all the way across. It's too big for my base. The base would be the 8, and the height would be the 5. So it's going to be 8 times 5 for the first rectangle. Plus, looking at the second rectangle, my base, again, the 10 is the whole way across. So if I just want this little bit, I would do 10 take away 8, which makes this part 2 meters for my base, and the 9 would be the height. So 2 times 9. You can put that whole thing into your calculator in one go so that we're still doing this question in 3 lines. 8 times 5 plus 2 times 9, and we get 58 meters squared. Question J. We have an outside rectangle, and we want to subtract off the inside one so that we can find the shaded area. So we're going to call the outside rectangle rectangle number 1. The inside rectangle is going to be rectangle number 2. When it comes to making a formula, the formula for a rectangle is A equals BH for the first rectangle. This time, because I'm cutting it out, I'm going to subtract the second rectangle, which is BH. But they're two different sized rectangles. So this is rectangle number 1, and this is rectangle number 2. So the base and the height of the big rectangle will be the 10 times 6. 10 times 6 minus. Now looking at the little rectangle, the 7 is the length of the width there, and 2 is the height. So 7 times 2. Put that whole thing in your calculator, and you get 46 kilometers squared. Okay, K looks like an easy enough question. We've got a normal triangle there, and the formula for a triangle would be A equals half BH. The trick with this question is that the base and the height should always be the two sides connected by the right angle. So it should be this side and the bottom side. So the 19 that I have here is the wrong side to use for the formula. I need this one down here, which I don't know. So I've put a little A on there. I'm going to have to find it. To find that side, I'm going to use Pythagoras' theorem. I'm finding one of the shorter sides because it's one of the ones next to the right angle. The shorter side formula is A equals the square root of the hypotenuse squared minus B squared. Subbing into that formula, the hypotenuse is 19 minus the 17 squared. In the calculator, that gives you 8.49 centimeters. So that's this side, 8.49. Now to find the area of the triangle is half BH. The base and the height is the 8.49 and the 17. So half times 8.49 times 17 equals, in the calculator again, it equals 72.12 centimeters squared. Question 2. A parallelogram has an area of 26 meters squared and its base length is 13 meters. What is its perpendicular height? So a parallelogram looks a bit like this. Pushed over rectangle, has parallel sides like that. The base length is 13 and we're trying to find the height, which would be that measurement there. The formula for the area of a parallelogram is A equals BH. But we're told that the area is 26. So we go 26 for the area equals, base is 13, and the height, which is H, I'm trying to find. What I've done is I've made an equation. To find out what H is, I need to solve my equation by doing the opposite. The opposite of 13 times by H is to divide by 13. That will get rid of the 13 here. H will then be by itself. 26 divided by 13 is 2, and that would be meters. So the height of that parallelogram is 2 meters. Okay, it's time for you to go to your workbook and do pages 18 to 21.